Hello and welcome to our session on Turbocharged Golang. The agenda for the session is as follows. We will start with an introduction of who we are, what we do, and what inspired us to deliver this talk in the conference today. We will take a brief look at the history of the web and the current state of affairs. We will have a look at the Hotwire toolkit, the problem it tries to address, and especially at Turbo, which will be followed by a demo. So, who are we? Hi, I am Utsav, and my co-presenter Chidambaram, or Chich as he is nicknamed, are both senior technologists at Infosys. We have worked on various domains like identity and access management, platform engineering, and ad tech. We are also the co-leaders of the Gophers Guild. At a few words on the guild. Gophers is a Golang user group at Infosys. We act as consultants to the wider organization on everything related to Go. The idea behind forming this group was to provide the Go developers in the organization with a forum where they can share their learnings, come with their challenges, and also work on some cool project ideas that can later be used as accelerators in one or more of our many client projects. Accelerators give us freedom, as in there are no prescribed requirements to start with. We can innovate and improvise as we go. They give us the opportunity to explore and experiment with new tools and techniques. But on the flip side, we need to work with the limited bandwidth of our fellow developers who take time out of their busy schedule to participate in this endeavor. Thus, we need to set realistic milestones to make sure we make progress within the constraint. After having a roadmap in place, it becomes imperative to carefully pick and choose the tools we use to build the application. Not only should the toolset help us reach our goal, but also complement the strengths and interests of the developers working on the project. And hey, side projects should be fun, right? This is a typical modern tech stack, with each layer designated to handle specific functionalities like user interface, business logic, and data management. Picking the best options from each layer can be a difficult task. With options offering similar features, it becomes even harder. We were sorted on the server-side technologies. We knew what we wanted to use. Our favorite language Go for building the backend. We repurposed a Postgres instance that was used for a POC earlier. We also found a VM to host our application on. While we were deliberating on which framework to use for our front end, there was a moment where we asked ourselves, do we even need one of these frameworks to build the front end? Can't we just stick to plain old HTML and CSS? But at the same time, we wanted to be sure we do not end up building a product that looks and feels like something from a bygone era. At this point, I would like us to look back at the history and evolution of the web. In the 90s, we had technologies like CGI script, PHP, and HTML. Times were simpler. The backend application would render the UI and send it to the browser to be displayed on the screen. The 2000s saw the rise of web APIs. Thanks to Ajax, a technique that allowed for the asynchronous updation of the page without refreshing the screen. In the 2010s, with more and more people making use of the internet, service providers started finding it increasingly difficult to scale their offerings to cater to the rising demand. This decade saw many notable advancements in software technology to deliver services at scale. SPAs, or single page applications, came about during that time to address the challenges of scale and a few other evolving needs. And by the end of the decade, it led to its proliferation with multiple such libraries and frameworks offering similar functionality. Fast forward to today, most of the services and applications we use on a day-to-day basis are powered by SPAs. Sadly, developers treat SPAs as the default option or sometimes the only option for building front end. Irrespective of whether our solution would really benefit from what SPAs have to offer, and despite the technical requirements and complexities SPAs bring along with them. In our quest to find a simpler approach in building front ends for the 2020s, we stumbled upon the Roca style. It turns out a group of developers had faced the same dilemma as us. Their collaborative efforts and shared experiences resulted in a set of recommendations based on well-established concepts like REST and progressive enhancement. Roca, or the Resource-Oriented Client Architecture Style Guide, is a set of recommendations for building web application front end. The recommendations are based on a few well-established ideas like unobtrusive JavaScript, progressive enhancement. Those are related strategies for building front ends that offer the core features to all its users while providing enhanced experience to users with modern browsers. The guide also recommends building server-side applications that return semantic HTML that is independent of the layout information. Enter Hotwire or HTML over the wire is a toolkit that aligns with the recommendations made in the Roca style guide, like the usage of semantic HTML and unobtrusive JavaScript. The toolkit is part of the Rails ecosystem and is running in production for apps like Basecamp and Hey.com. Hotwire consists of three libraries: Turbo, that lets you decompose your page into independent segments that can be updated independently. Stimulus is a lightweight JavaScript framework that gives you the means to attach JavaScript to HTML elements using simple annotations. And Native, that lets you run your Hotwire application natively on Android and iOS based devices. This is your typical flow with SPAs. You have an application written in JavaScript that runs on the browser. It interacts with the backend server by making asynchronous calls, and on receiving a response, it processes the data and then proceeds to update the page without reloading the complete page. Turbo offers you similar capabilities without you having to write even a single line of JavaScript code. Turbo lets you decompose your web page into independent units called frames, which enables the underlying library to uniquely identify and update these elements when a page navigation occurs or when a form submission event occurs. In situations where you don't want to replace an entire section with something new, but you would rather append or prepend a new element to it, you have the option of making use of turbo streams. It gives you 9 different options for manipulating elements in the DOM. Turbo streams also has support for WebSockets and server-side event. So in situations where you want your server to push updates to your front end, you get it out of the box. Okay, now it's time for a short demo. Okay, so this is a simple application that has a form, and when you type in your name and submit the form, you are shown a greetings message here. So if you look at the code, this is the main Go file where we have the application running. So if you look at the backend code, here we've got two handlers, the index handler and the greet handler. The index handler is used to serve the index page, which has the form. And then the greetings handler, it is a post endpoint, which basically accepts the form value and it executes the greetings view, and it displays the greetings message. So also note that we have added a synthetic delay of 100 milliseconds to simulate the application in the real world. So if we look at the templates here, so we can see we've got two templates. We've got index and greetings. So the index template here consists of the form and a heading. The greetings, it has the same heading and also the paragraph tag, which contains the greetings message. We have also extracted the header and the footer of our application into individual templates. We are calling it header and footer, and we've put them inside the layout subdirectory. So the header contains the head tag, the starting, the opening HTML tag, and the opening body tag, whereas the footer template contains the closing body and HTML tags. Now, this application does not make use of any of the Hotwire constructs. So if we submit this form again, and if we look at the network tab, so you'll notice that the server responds with a new web page, and the browser has to reload the web page to display the greetings message. Now, what if we want to make sure that we can display just the greetings message without having to reload the entire application? So now let's quickly jump to the other branch where we have implemented Turbo Frame. Cool. So here first we need to include the Turbo distributable in our application. So here we come to the header layout and we include the distributable in a script tag. Then we need to modify the the template. So here, if we look at the index template, so just above the form type, we have added a turbo frame type with the ID of message. And notice we have removed the greetings template or the greetings view, and we have moved it into partial. So now this, instead of returning a new page, what this will do is this essentially becomes our API, or rather the response of our API, of the greetings API. So when the greetings API gets invoked, it renders this view or this partial, and it returns this as the response. So here we've got a turbo frame element with the ID message. And here, if we go back to our index template, so what we can notice is we have this turbo frames tag right above the form, which will get replaced once this browser receives the response from the backend. And here also we have provided an attribute data turbo frame, which tells Turbo which particular turbo frame to update when it receives the response. So now if we run this application, let's go to the index page. Cool. And if we enter our name and submit it, then we can see that this changes to an XHR request over here. So we can see it's a fetch request. And the server responds with this turbo frame, which then is updated which then Hotwire or Turbo uses to update the DOM. But what if we don't want to place the entire element? What if we want to append the response to one of the existing elements? So, say for example, a chat application, right? Where when you're chatting, when the user is interacting with the web application, you would want to ideally what you would want to do is you would want to append the messages as and when they come. So let's take a look at a chat application, a sample chat application that we have built. So this is a sample chat application where the user can come and enter a message. So I can ask a question like, can you tell me about the 42 conference? Now, this particular version does not make use of any of the turbo features. So if we look at the network tab now, if we send this message, we can see that the backend responds with a new page, which is then rendered by the browser on the screen. If we take a look at the code, so here, if we look at the backend code, we've got one addition in terms of services. So we've got a Gemini service, which is basically a thin wrapper over an HTTP client, which helps us communicate with Gemini and get the chat completions. And if we look at the templates, so for this application, we have a single template. So this is the index template. So here we have the form which lets you type in the message and send it. And on top of that, we are rendering the messages that we receive from either the user or from the bot. So that is done by storing the message in memory. So we have a message struct, and we've got a sender and a text. So the sender can either be a human or a bot, and the text responds to the corresponding message. And we have a struct called messages, which includes an array of messages. And so as and when we receive messages, so whenever we receive a new request, we add that message into the array. And then when we get the corresponding response from the Gemini model, we'll add the message marking it as bot, or as a bot message. So this is what the application looks like. It's a pretty simple application. So every time you send a message, the request goes to the backend. It basically gets the response from Gemini, then renders the view along with the message history and sends it back to the user. Now, if you want to make this process asynchronous, and if you want to make that partial update, then let's check out Turbo. Cool. So here, if we look at the index, so the routes don't change. We still have two routes. So one is the index handler, and which basically serves the index dot, which serves the index view. And then we have a chat handler, which basically accepts the or takes a request, extracts the message, gets the completion from Gemini, and it sends back the message segment partial. So here, what the change that we can see here is, instead of a template which gets rendered here, we have a div tag with the ID messages, which provides a target, which can be used as a target identifier by Turbo to make the partial updates. Now, if we look at the partials, so we have created a new partial called message segment. So as you can see, the API, the chat API now basically returns a Turbo stream element with a few instructions for Turbo for this. So we've got an append, we've got an action attribute which says what to do with the response. So here it clearly mentions that we want Turbo to append the response to the target, and here we need to pass the target identifier. So we pass messages as the identifier. Turbo looks for an element in the DOM with the ID target, and it appends the response to it. So another thing to note here is that your response needs to be nested inside the template tags for this entire mechanism to work. And the final change that we need is, if we go back to main. So now, if you notice over here, we were setting the content type to text HTML in the previous cases where we were just sending back the entire HTML page. Even for Turbo frame, it works if you send the response. If your response contains a header which signifies the content type is text HTML. But in case of Turbo Stream, we need to set it to text vendor turbostream.html. Otherwise, it does not work for some reason. Okay, so now let's run this application. Cool. We go to localhost 8080. Right. Now we can ask the same question. Now notice that the request changed to a fetch type, and the response that we received from it. Okay. So the response here, it looks like this. And we can continue chatting with this, right? So say, when was the first conference? When was the first conference? Okay, so we have the answer here. And if you look at the response that we received, it's just the last message. So now it's not sending the entire HTML page. It's just sending the response to the previous request. Okay, so we can continue this conversation. Is Golang functional programming language? So as you can see, the backend only responds with only the code segment that it wants Turbo to append to the messages div. Make sure you check out our repository GoChatTurbo, where we have implemented a chatbot application using WebSockets and integrated it with Turbo Streams. So, how has the journey been for us so far? We have embraced some of the recommendations made in Roka Style Guide to keep our tech stack lean yet effective. As a result, we have a single repository and a single pipeline for the entire application. We also noticed 50% reduction in effort compared to our original estimates with SPA. And finally, we have a happy bunch of developers who can work with a simple set of tools. We encourage you to visit the website of Roka Style Guide and have a look at the recommendations. And also give Hotwire a try for your next side project. Thank you for joining us today. Until next time, goodbye.